Now we're going to explore some rules for exponents. When you combine like terms, and we mentioned this before, but it wasn't really relevant, you can only combine terms that have the same variables and the same exponents. So x, negative 4x, 7x, those are all like terms because they all have an x. We could combine those terms if they were all in the same expression. X and x squared, even though they have the same variable, are not like terms. The variables have to match and the exponents have to match, or you're not allowed to combine them. Now, if you are allowed to combine, you combine by adding or subtracting the coefficients, that's the numbers in front of the variables, and you do that according to the sign rules. The variables just stay intact. If I have 4x plus x, x is a like term. So I may combine 4x plus x. I do it by combining 4 plus 1, which is the coefficient of x, and that would equal a total of 5x. 3x squared taken away 2x squared, I can combine those. Those are like terms because they both have an x squared. I do that by combining the coefficients. 3 minus 1 equals 2, and then I keep the x squared intact. 4x plus 3y minus 2x plus y, we have a variety of letters. We just have to identify the ones that are like. That way they can be combined. 4x and negative 2x are like terms. Now the negative comes in front of the 2, so it is part of the term. 4x take away 2x, 4 minus 2 leaves 2, and I keep the x. 3y and y are like terms. Positive 3y plus 1 more y is going to total positive 4y. Now notice, 2x plus 4y doesn't make 6 of anything. X and y are not the same letter. They cannot be combined. 2x plus 4y is my final answer. Now if I look at number 4, let's start from the left and go to the right. Do I have another term that has an x squared? I do not. So 4x squared doesn't combine with anything. That doesn't mean it disappears. I just can't add it to anything. Now what about 3y to the third? Does 3y to the third have a like term? No. So I just carry it along. Negative 2x. Can I combine x with anything? No. And likewise, there's nothing in common with y. So that, even though it had 4 terms, that polynomial was already simplified. There were no terms left that I could combine. Oftentimes, it's the simplest looking problems that are the trickiest. X plus x means 1x plus 1 more x makes 2 x's. X squared plus x squared means 1x squared plus 1x squared makes 2x squared. When I combine like terms, I add the coefficients, the numbers in front, or subtract them if the sign rules justify that. But the actual variable part of the term stays exactly the same when I'm adding or subtracting. Now if I want to multiply, I'm going to multiply kind of like pieces and parts. I'm going to multiply my coefficients by following the sign rules. Now when I multiply terms that have exponents on them, I actually end up adding the exponents and keeping the base the same. And I'll illustrate that on the first problem. All of these things are being multiplied together. 5x squared means 5 times x squared times 3 times 3x squared. Now we look at it as like two terms multiplied together, but actually all those individual pieces are being multiplied. If I rearrange this, I'm actually talking about 5 times 3. And I'm also talking about x squared times x to the third. Now the 5 times 3 part's really quite simple. That's just 15. But what happens with this business over here? Well, it's kind of easy to see if we expand it. If I look just at the variable part, x squared means x times x. X to the third means x times x times x. So if I have x squared times x to the third, that means I have x times x for the x squared, x times x times x for the x to the third. Those two bunches are being multiplied together. Altogether, I have 5 x's being multiplied by each other. Five times 3 gives me 15. X squared times x to the third is going to give me a total of 5 x's multiplied times itself. And the way I write that is x to the fifth. Multiply your pieces and parts. Negative 4 times negative 6, negative 4 times positive 6 is negative 24. If I have x times x, remember no exponent means there's an invisible 1 there. X times x is x squared. Add the exponents. 3 times 6 is going to be 18. How many x's do I have multiplied together here? Here's 1, here's 3 more. That makes a total of x to the fourth. How many y's? Y to the second and y to the fifth means I'd have a total of 7 of those y's stretched out and multiplied together. That's y to the seventh. Negative 2 times positive 9 is negative 18. X times x squared, that's a total of 3 x's multiplied together. Y to the second times y to the second is y to the fourth power. And z doesn't get multiplied by anybody, but that z doesn't go away, it just stays z. So you don't lose anybody, you just total up how many of them are being multiplied.